Everyone has a story. The story behind mathematics is lengthy. It is traced back to the most ancient civilizations. The stories behind these theories are important because they show you the way mathematicians came up with ideas. It is a part which most people overlook when they study math. The use of mathematics is rather abstract in the modern world. Everything we know is nicely laid down by forerunners. There is not the need to create units of measurements or theories of our own. It is developed as the need for a number system arrives, often triggered by daily needs, administration, and engineering. The most ancient areas in mathematics are arithmetic, algebra, and geometry. That moment was sparked 7,000 years ago in ancient Egypt and Babylon. While mummies are prepared on the altar, Egyptians used simple arithmetic and algebra to work out calculations in daily life, in commerce, and in state administration. They applied mathematics to calculate simple and compound interest on loans and mortgages. Geometry was applied to calculate the areas of fields, to estimate the volume of buildings, and to calculate the materials needed for construction. However, it was not until the classical Greek period that mathematics was considered an area of study on its own, a study of reasoning that is purely intellectual. The Greeks established the mathematical school of thought. Basically, they established the school of thought for almost every single study we have nowadays, like the political science, philosophy, history, and natural science. So, what's the difference about their thoughts? They see the natural world as a purely rational and mathematical world. They disregarded supernatural causes, traditional doctrines, dogma, and authority. They investigated the world for the sake to satisfy their curiosity. That is why they have developed a clear system of reasoning that made them the founders of science in the true sense. In the calculus context, Democritus was the first person recorded in history who considered the division of objects into an infinite number of cross-sections seriously. It was a pity, though, that he was unable to rationalize discrete cross-sections with a cone's smooth slope, which prevented him from accepting the idea of calculating the volume of a cone by summing up the volumes of the cross-section. Another key figure of the ancient Greek period is Archimedes of Syracuse. He was the first to find the tangent of a curve other than a circle in a method akin to differential calculus nowadays. While he was studying the spiral, he separated the point's motion into two components, which were the radial motion component and the circular motion component. So, what prompted the mathematicians to look at the tiniest division of a unit? The development of calculus is traced back to the early Renaissance period, which we categorize the early development of calculus into three time period: the anticipated, the developed, and the refined. During the anticipated period, the foundation for infinitesimal calculus were built. Much of the discovery and development made early in this time period was related to the study of geometry and algebra in the previous era. And during the developed period, mathematicians developed theories and concepts based on the ground Newton and Leibniz set in the late 17th century. As the ground was laid, there was the room for imagination and possibilities. Finally, in the refined, approximately from the 19th century onwards, mathematicians seek detailed discoveries in calculus to focus on the smallest key concepts possible in order to increase the scope of calculus. The development of modern-day calculus came to shape in the 17th century, which it was the time of the Renaissance in which the scientific revolution took place. New ideas flourished. Scientists and mathematicians look at the world in an analytical point of view. During the anticipated period, the development of infinitesimal calculus started with one thing, which was the idea of a derivative. Now, calculus simply could not work without a Cartesian plane. For this, we have to thank Descartes. Well, he expressed algebraic equations as geometric shapes in two-dimensional coordinate system. This is the Cartesian coordinate plane that we cannot live without in the study of calculus, and yes, it was named after him. And that is why he was named the father of analytical geometry. His contribution was significant to the discovery of infinitesimal calculus and analysis. In the context of integral calculus, much of the discovery made was related to the calculation of the area of a certain shape or the area under a curve. Now, like Cavalieri, He wrote about the method of invisibles in the 30s and the 40s. The method was a modern form of the ancient Greek method of exhaustion, which was a method to find the area of a shape done by inscribing a sequence of polygons into the shape, in which the sequence of the polygons converged to the area of the shape. Later, his work was further developed by Torricelli. Torricelli was an Italian physicist and mathematician. He was famous for the discovery of the Torricelli's trumpet, which described that the surface area of the horn was infinite while the volume of the horn was finite. The story was then followed by Fermat. He was an amateur mathematician who developed an adequate method for determining the maxima, minima, and tangents to various curves, which was equivalent to differentiation in modern days. Isaac Newton once said that his very own early ideas about calculus came directly from Fermat's way of drawing tangents. Now here comes the controversy of the discoveries made by Leibniz and Newton. As we know, both made tremendous contributions to the development of calculus. The debate still goes on and creates much hatred among the two parties. Who took the first step in making the discovery remains to be debated. Newton was lip-tight and secretive about his discovery in calculus and physics during the time of 1673 to 1686. He did not publish the Principia until 1687. Now here the controversy stands. Historians have found that Leibniz discovered his version of calculus in Paris between 1673 and 1676. Leibniz then published his first work on differential calculus in 84 and published his first work on integral calculus in 86. Although evidence has shown that Newton made the discovery before Leibniz, many of the credits were given only to the later, as Newton delayed his publication. So they both made really similar discoveries in almost the same period of time. What could they have communicated in some way that reviewed the work to each other? Well, they wrote letters back and forth. Newton wrote about his methods, formulas, and concepts of calculus and to Leibniz. However, it is also found that Leibniz made the discoveries before Newton ever told him about it. So here comes two possibilities that Leibniz plagiarized Newton's work. First is that in 1675, the both were working on a project together, and by May, Newton's manuscripts were sent to another place. It was possible that Leibniz picked up a few pieces of his work at that time. And the second possibility was that the third party held Newton's manuscript as well. The third party was a mutual friend of Newton and Leibniz. That way, Leibniz could have got hold of the work. In this case, the third party was Collins and Nottenburg. In fact, before Leibniz died, in a letter to Conti, he admitted that Collins had shown him some of Newton's papers. However, he firmly denied that the papers were of no significant value to his findings. In 1715, the Royal Society gave out a verdict crediting Sir Isaac Newton for the discovery of calculus. The verdict also stated that Leibniz was guilty of plagiarism. They accused him for having seen some of Newton's letters before his own work were published. Although Leibniz had developed his own set of symbols, which was different from the Newton's, some insist that he was guilty because the difference in symbols was to act as a cover-up of his crime. Leibniz developed the I sign for integrals and the D sign for differentials, which were still used in modern calculus. Later, the Royal Society's verdict was proven to be wrong, even though Newton and his supporters would not give up on the accusation. The controversy created many negative effects on the British society, and they refused to educate the youngsters of all mathematical discoveries except Newton's. As a result, the country's development was lagged behind for almost a century. Looking into the history, we see that the development of calculus was rigorous. What we have learned from history is not only the great discoveries these mathematicians made. Mathematics is way beyond simple numbers and symbols. It is a study of logical reasoning, of creativity, of imagination, of politics, of the society. It is a study that connects different aspects. Often have we mistaken the intention of mathematics as it becomes a complicated compulsory course in school. But if we try to appreciate the natural beauty of math, then we will see the other side of the complicated school course. It is in fact the combination of human mind logic and natural laws.